Earned value concepts. Welcome everybody. This is Cesar Ramos with Advanced Planning and Analytics. History of EVM. So the question is, so why the history? In my opinion, if you don't know where you've been or come from, you may not know where you're going. I'll put a high emphasis on history because I feel that it's the key to understanding and knowing that earned value standards and guidelines exist. Your company may have some written guidelines, but what I've found in most companies don't include the entire spectrum of earned value or any at all. They, in most cases, use a software, in this case, predominantly P6, and they do everything out of the software, but they don't even know that earned value standards and guidelines exist. This is a very common issue. And as an example, numerous major EPC companies and construction companies only track production factor. They'll only be after or track the PF, also known as productivity index if they're using that calculation, or an EVM is the CPI or the CPIE, which is efficiency. Those in earned value know what this is only a portion of earned value analysis. So if you're only looking at productivity or productivity index or CPI out of your reporting, then you're not looking at the full spectrum of earned value. A quick history of project controls. Critical path method. Now, why would I bring up critical path method? I want to point out that critical path and earned value are not the same thing. Critical path was a project modeling technique that developed in the late 1950s, from 1943 to the 50s. Walker and Kelly of DuPont and Remington Rand related their memories to the development of CPM in 1989, and they attributed the term critical path to the developers of the program evaluation and review technique, which is called PERT. This branched off into another methodology that we recognize as risk. So the precursors of what became known as critical path were developed and put into practice between 1940 and 1943. They even contribute to the success of the Manhattan Project. Earned value management emerged as a financial analysis specialty in United States government programs in the 60s. So keep in mind that CPM started in 40s and 50s, and in parallel to that, they were still tracking cost and things, but earned value management really emerged later into the 1960s. Project management research investigating the contribution of EVM to project success suggests a moderately strong positive relationship. Implementations of EVM can be scaled to fit projects with all sizes and complexities. Earned schedule is an extension to the theory and practice of earned value management, and as of 2005, earned schedule is designated as an emerging practice by the PMI, which is Project Management Institute, and it was introduced in 2003 by Walter Lipke. So this is a timeline of earned value and its history from the Department of Defense and its implementations from the 60s to the early 2000s. I'm not going to read everything on this grouping, but you could pause the video and feel free to check it out. And more on history. The genesis of EVM occurred in the industrial manufacturing at the turn of the 20th century, based largely on the principle of earned time popularized by Frank and Lillian Gilbreth, but the concept took root in the United States Department of Defense in the 1960s. The original concept was called PERT cost, but it was considered overly burdensome and not very adaptable by contractors who were mandated to use it, and many variations of it began to proliferate among various procurement programs. In 1967, the Department of Defense established a criterion-based approach using a set of 35 criteria called the Cost and Schedule Control Systems, or also known as CSCSC. In the 1970s and early 1980s, a subculture of CSCSC analysis grew, but the technique was often ignored or even actively resisted by project managers in both government and industry. CSCSC was often considered a financial control tool that could be delegated to analytical specialists. In the late 1980s and early 1990s, EVM emerged as a project management methodology to be understood and used by managers and executives, not just EVM specialists. In 1989, EVM leadership was elevated to the Undersecretary of Defense for Acquisition, thus making EVM an essential element of program management and procurement. In 1991, Secretary of Defense Dick Cheney canceled the Navy A-12 Avenger II program because of the performance problems detected by EVM. This demonstrated conclusively that EVM mattered to secretary-level leadership. The use of EVM quickly expanded beyond the U.S. Department of Defense. It was adopted by the National Aeronautics and Space Administration, NASA, and United States Department of Energy, and other technological-related agencies. Many industrial nations also began to utilize EVM in their own procurement programs. An overview of EVM was included in the first PMBOK guide in 1987 and expanded in subsequent editions. Also, I'll note that PMI has also published their own earned value book. The construction industry was an early commercial adapter of EVM. Closer integrations of EVM within the practice of project management accelerated in the 1990s. In the 1990s, many U.S. government regulations were eliminated or streamlined. However, EVM not only survived the acquisition reform movement, but became strongly associated with the acquisition reform movement itself. Most notably, from 1995 to 1998, ownership of EVM criteria reduced to 32, was transferred to the industry by adoption of ANSI 748A standard. In 1999, the Performance Management Association merged with the Project Management Institute to become PMI's first college, the College of Performance Management. The United States Office of Management and Budget began to mandate the use of EVM across all government agencies and for the first time for certain internally managed projects, not just for contractors. EVM also received greater attention by publicly traded companies in response to the Sarbanes-Oxley Act of 2002. Yes, this is one of the primary reasons today that EVM has now solidified its foothold because of the Sarbanes-Oxley Act and the incidences associated with it that most of you guys know, the Enron situation in Houston, Texas. That's what caused this, and now it's solidified as a tool to recognize and get greater attention. So let's go back in history, way back. For those of you interested in the history of EVM, a must-have book for your library can be found in Google Books. The title is called Cost Keeping and Management Engineering for Engineers, Contractors, and Superintendents Engaged in Management. Written by Halbert Gillette and Richard Dana in 1909. In this book, he provides several charts and graphs showing progress, but the most relevant can be found on page 103, where we can find SPI and CPI plotted exactly as we use today, which the authors labeled appropriately enough efficiency chart. This is an interesting read because there's argument of the origins of EVM and or when it really was initiated. It's considered the smoking gun proof that EVM predates the typical historical timeline of the 1960s. This was published in 1909. And as many of you know, there are a few of us who have been saying that we've been using earned value, including the use of earned time and earned schedule, as an integral part of earned value going back to the 1960s. Again, history is great. It's interesting. If you want to understand really the origins and the intent, you can go all the way back as far as 1909. Or if you continue to research, you may end up all the way back to quite possibly when they started erecting monolithic structures or these organized structures in the Egyptian days. So enough of history. A lot of folks aren't interested in that. They want to learn the concepts. So I'm going to go over what we call the EVA concept, the synopsis of earned value analysis. The proper term for earned value analysis is correct. In most cases, you're going to hear the term earned value management, EVM, but in reality, the analysis is part of it. So it should be recognized as EVA. So earned value analysis is defined as earned value, the periodic, consistent measurement of work performed in terms of budget planned for that work. Complying with ANSI 748 definition, earned value is the value of completed work expressed in terms of the budgeted assigned to that work, also referred to as budgeted cost of work performed. BCWP. EVA integrates all three. So earned value compares the planned amount of the work with what has actually been completed to determine if cost, schedule, and work accomplished are progressing as planned. Work is earned or credited as it's completed. Earned value is a direct relationship between percent complete of an account and the budget for that account, also known as percent complete times the budget for that account is your earned value. Progress measurement is part of earned value, and it has 6 common methods. The first one being units completed, example, wire pulling, foundation, linear feeder pipe installed. It could be incremental milestones, such as on drawings or engineering drawings. You'll see the rules of credit associated with issue for design, issue for construction, etc. Start and finish rules. Example, testing for commissioning, pre-commissioning. You either tested it or you didn't. Sometimes you'll have a supervisor opinion. This is where it becomes very subjective, and we kind of try and stay away from subjective progress, because that just means that there's no way to substantiate that progress. There's also cost ratio, level of effort calculation. In some cases, actual versus forecast at completion. So sometimes you use time as a weighted value. Cost ratio, it's just a day-to-day linear distribution. And of course, you could use weighted or equivalent units. So if you had weighted units, then you could establish some rules around earning certain progress by weighted units or weighted values. Here's an example. You'll see deliverable 1 in green. The weight is man hours. Let's assume this is an engineering progress. And when you start, which is go, you're going to earn 5%. When you issue for review, you're going to earn 25%. When you issue for approval, you'll earn 35%. When you issue for design, you'll earn the 50%. And then when you're issued for construction, you'll earn that 100%. So at every one of these intervals over time is what starts to establish this curve here below that shows those values. Deliverable 2 has 600 hours, same rules of credit. However, there is an intermediate credit here at IFC in October, and the increments are different. And then below, when you compile the curves together, you'll see that they end up creating that normal S curve as we recognize. Construction progress rules of credit work the exact same way. Here, top right, the weight, let's assume this is 1,000 cubic yards that converts to man hours. Let's assume 1,000 for right now. These are foundations. When you start your foundation, you'll get 5%. When you go to your excavation, you'll get the 20%. When you rebar, you'll get another 20% and get to 40. And then when you form, you'll get the cumulative 60%, 80, 90, 95, and 100. So you have your periodic gains, 5, 15, 20, 20, 20, 10, and 5, and 5. And then the cumulative gains shows the progression that gets you to 100% as you see on this curve. Sometimes we look at the earned value, both in periodic values and cumulative values. So going to EVM abbreviations, AC is actual cost, or the actual cost of work performed. Now, ACWP is the original terminology used in most of the literature, including ANSI and these other industrial best practices formed. But the project controls community has adapted to shortening the terminology, as you see here, AC. And for EV, meaning earned value, in the proper terminology was budgeted cost of work performed, which was BCWP. You have planned value, which is PV, budgeted cost of work scheduled, and EAC is estimate at completion, ETC is estimate to complete, and these terminologies, some of these terminologies you see here, ACWP, BCWP, and BCWS, may still exist in some literature, so be aware of it in case you ever run across any requirements or contractual requirements. There's 3 types of variances. You have a schedule variance, known as SV, a cost variance, known as CV, and a variance at completion, known as VAC. So on the top, we have variances, which is earned minus actual is your cost variance. And then on the right, you have earned minus planned value is your schedule variance. Below, we have indexes, and the indexes are divided. So here you have earned over planned for SPI, which runs in catty corner from here. And you have CPI, which runs catty corner here, is earned over actuals. Those provide you indexes. Indexes are also used to recognize results. Here we'll see schedule variance, earned minus planned, also known as BCWP minus BCWS. And it's a comparison of amount of work performed during a given period of time to see what was scheduled to be performed. A negative variance means that the project is behind. Cost variance is earned minus actual, also known as BCWP minus ACWP. A comparison of the budgeted cost of work performed with actual cost. A negative variance means the project is over budget. Indexes. SPI is your schedule performance index. Here it's earned value divided by planned value, also known as BCWP divided by BCWS. An SPI less than 1 means project is behind schedule. CPI, cost performance index, is earned over actuals, also known as BCWP over ACWP. A CPI less than 1 means the project is over budget. CSI is your cost schedule index, also known as CPI times SPI. The further SCSI is from 1 is the less likely project recovery becomes. In a quick synopsis here, basically what we're saying is if your project is, let's say as an example, behind schedule, less than 1, and your CPI is ahead of budget, let's assume a 1.14 or 1.2, when you multiply the two together, we're really trying to find out the ability to recover back on plan. So that's what CSI is intended to do, along with your CPI and SPI. Estimate at completion, which is EAC. Here we've got the definitions of formulas, and there's multiple formulas for EAC. So your EAC is your prediction or your calculation for a forecast. Going through the first one, we're going to see here that the future cost performance will be performed at the budgeted rate. All we're saying at this case is ETC is add your actual cost plus your ETC is what your EAC would be. So remember that ETC is your budget minus your earned, which basically means remaining. So when you have remaining plus what you spent is what your prediction will be. If you incorporate future cost performances the same as all past cost performances, so in this case, if we say that BAC minus EV, which is ETC, divided by your productivity, your cumulative productivity, and then add that to your actual spent. So if we had a bad productivity, and if we want to be conservative and say, how are we going to perform if we continue with this bad productivity? When you take your remaining divided by that productivity and then add what you spent, that's kind of a prediction to say this is what we're going to end up being at the end of this. There's also other variations of performances. In this case, you can average the last or previous 3 months because you don't want to say that your bad productivity is going to continue throughout the entirety of the project. So maybe you could average a rolling past 3-month window to say what's the average of the past 3 months, and let's divide it by that. Also, you can take into account a recovery index, so CPI times SPI. So you could take that bad productivity plus your schedule performance index and then divide your ETC by that value to see what the prediction is going to tell you in terms of recoverability. And of course, sometimes the indices are purposely calculated, such as here, to say let's take a 0.8 CPI and a 0.2 SPI and let's figure what that prediction would be. So this source is from the PMI standard for earned value management as written by the PMI standard. But what I want to go next is to go into another definition of EAC is by sourced Humphrey and Associates and ANSI 748B, and this looks very similar in terms of computation. So you'll see they still reference the EAC formulas, which is AC plus ETC, and future performances takes into account your ETC divided by your CPI or CPIE, which is your efficiency. And then these other variations also still come into play. So they're almost the same in terms of calculation, but in my preference, I actually stick to Humphrey and Associates or ANSI 748B as the leading calculations. And what I want to go over now is a very common example of the curves as we know them today. This is a real good curve example. You'll see multiple variations of these curves, but I'll walk you through this. What you find is if this purple line here was your earned value curve, and let's assume this was your data date, this is basically telling you that up until this point, this is how far we've earned in our value, EV or BCWP. Our spent line or expenditure line runs in this ACWP line, also known as AC, actual cost. And you can see that it is greater than what we've earned. So the variance here, cost variance, you see, is your earned minus your actual is inverted. So in this case would be negative because we've spent more than we earned. But if we looked at our PV, our planned value is this red line, and let's assume this is our baseline, if you will, the target, which is BCWS or PV. And if you look at our point in data date time, we are planned to be a lot greater than our earned has been. So when we take our earned over planned or earned minus planned, this is our schedule variance. So not only are we not earning where we should have been, but we've also spent greater than we've earned. So in both cases, we are behind schedule and we're overspent. So what this does to the forecast, which is our EAC, tells us that the forecast is going to extend and exceed our budget because of these variations. When we run our productivity and our analysis into the equation, it's going to predict that we're going to overspend, and because of that overspend, we're going to end up here at a variance of completion that's greater than our baseline. And this is the BAC, if we call that, which is our basically our contract value or our budgeted value plus change orders. And our predictions tell us that we're going to exceed that not only in time, but also in budget. So we're going to be behind over budget and behind in time. I hope that helps you with your earned value concepts. And if you have any questions, please feel free to reach out to us.